Okay, na? Complete, Aditya?
Yes, sir.
Right. Now, next midpoint theorem. So this is the triangle ABC. This is the triangle ABC. So you draw a median. Suppose this is the midpoint. You draw one median. So this is the median. So this distance is So this distance is equal to this distance. So now we know that this total distance is equal to A because it is opposite to the vertex A. So this is A, and this one is median. So here midpoint theorem is, so AB square is equals to, so midpoint theorem is here AB square plus AC square. AB square plus AC square is equals to 2 times AM square plus BM square. 2 times AM square plus BM square. So this is equals to 2 times AM square as it is, AM square. So here BM is same as CM. That is equals to this BM. If we replace with CM, then this is equal to, what is AB length? Already we have seen yesterday, I have given the notations. So this AB is opposite to C, therefore this is denoted by small c, and this is denoted by small b. So here AB distance is equal to what? C square, small c square, plus AC distance is equal to small b square, is equals to 2 times, this is AM square plus CM is equal to A by 2. Yes or no? Because this is half of the side. Therefore, this is equal to A by 2. That is A square by 4. So now, if you isolate this 2 AM square, that is first 2 AM square plus this is A square by 2, that is equal to C square plus B square. Now isolate this AM square. For that one, what you get? 2 times first AM square is equals to, so B square plus C square minus A square by 2. That is equals to 2 times B square plus C square minus A square by 2. So this is 2 AM square. Now from this one, AM square is equals to 2 times B square plus C square minus A square by 4. So this is the result. So what is this here? This one is AM is nothing but what? Length of the median from the vertex A to this BC. This median length can be calculated in terms of ABC. Means if you know the lengths of the sides of the triangle ABCs, so we can find the median length. Yes or no? Here AM square is equal to this one. So median is equal to what? So we'll do this one. Therefore, that implies the length is always positive. That's why AM is equal to, so square root of, actually if you remove, if you take out the square root, actually you will get plus or minus, but distance never be negative. That's why you don't take negative sign. Generally, whenever you solve x square equal to A, x equal to actually plus or minus root A. Yes or no? Generally, but here AM is distance, that's why don't take this minus. Distance never be negative. So according to the context, we need to take. Here negative is not possible. That's why AM is equal to 2 times B square plus C square minus A square by square root of 2 is 4. So what is this? It's a length of the median AM through the vertex A. So this is length of median AM through the vertex A. This is the length of the median. So next what you do is, similarly, can you write the remaining lengths or not? Similarly, by symmetry we can write, so length of median through B is equal to, tell me, square root of 2 times. So easy to write here with respect to vertex A, means here we got here small a, here small bc's. So here through vertex B, in place of A you will have B here, here AC. By symmetry you can write, that is 2 times A square plus C square minus B square by 2. Yes, sir. Similarly, through C, what is equal to what? Minus here C square 2 times A square plus B square by 2. Clear? Next terms are, first one is parallelogram, quadrilaterals. So see, suppose see, now in this diagram, suppose this is A, B, C, D. So when we say the quadrilateral is a parallelogram, means suppose this angle is some alpha, this angle is beta, so then this angle will be alpha, so this angle will be beta. So first property is, in parallelogram, AB is equals to, AB side is equal to CD side, length of AB is equal to length of CD, and AD is equal to BC, AD is equal to BC, that is AB is equal to CD and AD is equal to BC. Next, second one is AB must be parallel to CD and opposite sides, and AD is parallel to BC. Third one, this adjacent angles are supplementary, that is sum of these adjacent angles alpha plus beta is pi. Next, fourth one is diagonals bisect each other. Bisect each other. So these are the properties of parallelogram. So here the diagonals bisect each other means, suppose take the same diagram. See, in this diagram, so diagonals bisect each other means, see, right? See, so this is one diagonal. So this is another diagonal. So the diagonals bisect each other means, so this is M means, so this distance is equal to this distance and this distance is equal to this distance. Yes, sir. In parallelogram, diagonals bisect each other. So in general, in a parallelogram, the lengths of the diagonals are not equal. In general, yes, sir. So in general, in a parallelogram, diagonals otherwise diagonals lengths are not equal in general. So this is about parallelogram. So means to one quadrilateral is given, that is the vertices of the quadrilateral is given. Then to prove the given quadrilateral is a parallelogram, then how can we prove? First one is here alpha plus beta is pi, that is adjacent angles are supplementary, that is alpha plus beta is pi and gamma plus delta is equal to pi. Yes or no? That is the first thing. Second thing is AB is equal to CD and AD is equal to BC. That is opposite pairs are equal, lengths are equal. Or you can prove like this also. AB is parallel to CD and AD is parallel to BC. Or you can show diagonals bisect each other. If you show diagonals bisect each other, then it will be a parallelogram. Okay. These are the methods to prove the general given quadrilateral is a parallelogram. Okay, na? If you need, I will write. So to prove the given quadrilateral is parallelogram, to prove given quadrilateral parallelogram, first one is what? Alpha plus beta is equal to pi and gamma plus delta equal to pi. That implies that is adjacent angles are supplementary. Angles supplementary. Either you prove this one or you can prove like this, that is AB is equal to CD, AB length is equal to CD and AD length is equal to BC. That implies opposite pairs are equal. Or third way is opposite pairs of sides are parallel, that is AB is parallel to CD and AD is parallel to BC. Or you can do like this also, diagonals bisect each other. Diagonals bisect each other. So actually in general, in a parallelogram, diagonals are not equal. Yes or no? And diagonals will not bisect each other. In general, in a parallelogram, diagonals are not equal, neither equal nor bisect each other. By chance, they may equal, they may bisect each other. For example, because suppose you take why the diagonals will not bisect means, suppose you take the diagonal parallelogram like this. This length is like this. You take, if you take this length is greater, if you take the parallelogram like this, sorry, if you take the parallelogram like this, then if you draw the diagonal for this parallelogram, if you draw the diagonal for this parallelogram, the diagonal will be like this. So diagonal will be like this. Yes or no? Rough diagonal. So in this one, suppose this angle is alpha. Yes or no? This angle will be beta. So in this diagram, we can say beta is greater than alpha. Yes or no? Angle beta is greater than alpha. Therefore, in this diagram, diagonals are not bisecting. Sorry, diagonals, what we call? So this angle B is greater than angle B is greater than angle A. So diagonals will not bisect angle. Here it's not an angular bisector like that, we can say. See, diagonal is not an angular bisector because angle beta is greater than angle alpha. Okay, so that is the reason. Next, this is about what? Parallelogram. Next, second one is second quadrilateral is rhombus. Rhombus. So this is the special case of parallelogram only. The rhombus is a special case of parallelogram. Means, so for the rhombus, all the parallelogram properties will satisfy, and extra it has their own properties. Yes, sir. Rhombus satisfies all the properties of parallelogram, and it has its own properties, extra properties. So you'll write like this. So first I'll draw the diagram. Rough diagram. Okay. Okay, rough diagram. Right. Next, suppose this is A, B, C, D. A, B, C, D. Now what you do is, now in rhombus, this is diagonal. Here in rhombus, diagonals bisect angle, that is angle alpha and alpha. And all the lengths are same. Right. So, right, I'll write. So rhombus is a parallelogram in which all the sides are equal. All sides are equal. Next, diagonals are perpendicular to each other. So this angle is 90 degrees, are perpendicular to each other. Diagonals are perpendicular to each other. So here diagonals are also angular bisectors. So this first point, here diagonals also angular bisectors. These are the own properties of rhombus. So diagonal is a angular bisectors. In general, diagonals are not equal in rhombus. Again, in general, diagonals are not equal, but square is also a rhombus. In its diagonals are equal. Okay, square is also a special case of rhombus. That's why in general diagonals are not equal. In general, diagonals are not equal in rhombus. Not equal. But in special case, that is a square is a rhombus, in that one diagonals are equal. In general, it's not equal. Clear? This one rhombus. Next, third one is rectangle. So in rectangle also, all the properties of parallelogram satisfies, because rectangle is also parallelogram. So in rectangle, all the properties of parallelogram satisfies. Therefore, rectangle is a parallelogram. in which all angles are 90 degrees. All angles are 90 degrees. Next point is diagonals are of equal length. Diagonals are of equal length. Equal lengths. In rectangle. Also, diagonals will not bisect angle. Will not bisect angle. Not bisect angle in general. Yes or no? Here also, these two angles are not same rectangle. So diagonals are not equal. So this is about rectangle. Next, last one is square. So right, square. So in this one, A, B, C, D. Right. So here, right, in this square, I'll write here itself. Right. Diagonals perpendicular, comma, equal. Diagonals perpendicular, equal, bisect each other. Diagonals perpendicular and equal and bisect each other. And all the sides are equal. All the sides are equal. And all the angles are 90 degrees. All the angles are 90 degrees.